Hello friends, our today's question is container with most water. So what is given in this question is you are given an integer array height of length n. Okay. So what is given? We are given an integer array of size 9. Height integer array of size 9. Okay, so what is given? The size of the or we can say the height of each bar. Okay, so like the height of this bar would be the starting and end point of this bar would be like I comma 0 and I comma height of I. Okay, so height of I. So basically this is given in this question, like we are given an height array and the starting and the end point of these would be I comma 0 and I comma height. Okay, so we have to find two lines that together with the x-axis form a container. Okay, so like if we have seen a container, so what it will have, it has two height and a base. Okay, so the same thing we have to do. We have to find two heights along with the base x-axis, that it will form a container, and that if we store some water in this, so we have to find the maximum amount of water that we can store among these height. If we choose if we choose two indices or two heights among these heights, and along with the x-axis we have to find the maximum amount of water that can be stored. Okay, so the same, return the maximum amount of water a container can store. Okay, so the same thing, like to contain a water in any container, we have to it should have two sides, okay, and a base. Okay, so we have to find these two height such that this container will have the maximum amount of water. Okay, so if we test this, if we are having container like this, okay, so the maximum amount of water that can be stored in this is up till this height, the up till this height, because after this the water will fall from the container through this path. Okay, from the path with the lower height. Okay, so we can say that whether it is having a wall or or a side of more height, but it will only have water up till the minimum height. Okay, among these two sides. Okay, so the same thing, so we have to find among these columns, or among these height, we have to find two bars such that they will store the maximum amount of water. Okay, so I think the question is clear to us. Okay, so now for the approach to solve this, we will discuss two approach. Okay, so the first approach is like brute force using two loops. Okay, so what we will do, basically we will have one I and j. Okay, so what I and j will, I will iterate from 0 index up till n minus 1. Okay, I will iterate from 0 to n minus 1, and j will iterate from I plus 1 to n. Okay, so what we will do, we will place our I value here, and j will iterate for the whole from I plus 1 to n. Okay, so what we will do, we will for each one, okay, so for along with the point, for each vertical distance, okay, it will be of 1 unit. Okay, so we will have to take this as 1 unit. Okay, so now what we were so for each I, j will iterate from I plus 1 to n minus 1, and for each bar it will calculate the maximum water it can store, and we that count we will that we will store in our variable called maximum capacity. Okay, so each time what we will do, we will compute the amount of water that we can store in current 2 bar, and we will check it with the maximum capacity. If it is greater than the maximum capacity, we will replace the value of this variable. Okay, so this approach we can do. Okay, but what this approach, why we will not use it, because it will use n square of time complexity, because for each I, j will iterate from I plus 1 to n. Okay, so it will use capital O of n square time complexity. So we have to do, or we have to find a better approach than this. Okay, so for the second approach that we will use here is two pointer approach. Okay, so how we will use two pointer approach? Okay, so we will discuss that. So second approach we can use here is two pointer approach. Okay, so what we will do, basically what we have to find, we have to find two bars. Okay, so and we have to compute, we have two bars in our hand. Okay, and we have to now compute whether this can store the maximum capacity of water that we have from the one which we have previously got. Okay, so like we will have for example, we will have a variable max capi capacity. Okay, so we have initiated with okay, let me edit this with int min. Okay, so we have a variable called maximum capacity and we have initialized it with int min, so it will have the minimum amount that our integer value can have. Okay, so now we will have to take two bars and we have to calculate the amount of water it can store. Okay, so now if we have calculated and it comes out to be 1 unit. Okay, let's say for example, now we will check it with this the maximum capacity whether it is greater than the maximum capacity. If it is, then we will replace its value with the maximum capacity. So now maximum capacity will have 1 unit of water that can store. So for now our answer is 1. Now for each bar, like we have to check for each pair of bar. Okay, for these two, for these two. Okay, so how we will check this? So we will have one pointer placed here and one pointer placed at the end. Okay, so we will call them front and end. Now what we will do, we will find the minimum, as we have told, like if container is having a side not two sides which are not equal, so it will contain water up till the minimum height. Okay, minimum height of the side. Okay, so yes, like for these two case, one we are having we are having side as 1 and another side we are having is 7. So between these two we cannot store up till 7 because water will fall from the side of 1. Okay, so what we will have, we will have 1. Okay, now we have to compute how many what is the vertical or the breadth of this container will have. So 1 2 3 4 5 6 7 and 8. Okay, so 1 into 8, so what we get here is 8 capacity, 8 unit of water is can store. So maximum capacity has int min. Now it will have water as 8. Okay, so for now maximum capacity of water that this can store is 8. Okay, now what we will do again, now we will remove we will shift our pointers. But how we will shift our pointers? Like if here in this case we are having 1, like but we have the potential capacity, like okay, if this is the bar we are having, so if we are finding a bar less than this. Okay, so in that case the amount of water that we can store will decrease. But if we are having the bar above than this, so there might be a possibility then we can find a bar greater than or equal to this. So in that case our the amount of water that we can store in this container will always increase. Okay, so what we will do, we will choose the maximum among these two bar. Okay, so for that we have 8, for that we have 7. So we have chosen this bar as it is, so end will be same, but we will increment the bar, we will increment to the we will take the next bar which is the minimum in the previous one. Okay, so we will increment the front pointer. Okay, so what it has done now, like one for as we have discussed, like for if we are having a smaller bar and if we are having finding a bar greater than this, so there is a possibility that we can find a bar which is greater than and equals to this. So in that case we will increment the chances of having maximum capacity. But if we are choosing a lower bar than this, now in that case we are definitely decreasing our chance of finding the maximum capacity of the water. Okay, so in this case, so whichever the minimum will be between these two bar which we have chosen in our previous iteration, so we will choose from the minimum and we will increment the pointer of that bar. Okay, so friend will be pointing to this. Now again, so what we will have 7 and 8. So among 7 and 8, what is the minimum? Minimum is 7. And what is the distance between these two is 1 2 3 4 5 6 and 7. So it has 7. Okay, so it is 7 7 is 49. So now maximum capacity will contain 49. Okay, so in the same way we will iterate and we will iterate up till front is less than end, because we don't have to take a single bar two times. Okay, so if front is here and end is here, okay, so we have to iterate up till here, because we cannot have front and at end at the same time, because in that case we will not be able to form any container only. Okay, so this is the case. Now how we will compute this vertical distance? So if in case front is here and end is here, so how we will compute end? End will be pointing to index, so it will be 8, and front will be pointing to again index of the height array, so it will be 7. So for each time we will calculate f minus e minus f will give us the vertical distance, horizontal distance or the breadth. So it is 8 minus 1 7. So let us count 1 2 3 4 5 6 and 7. So yes, so we will do for, so we have checked, like we will place our front end and pointer, then we will compute the maximum amount that it can store, okay, and we will check it with the variable, our maximum capacity, whether it is greater than that or not. So if it is, so we will replace its value. Then what we will do, we will move our we will move our pointer on the basis of the small bar. Okay, if front is pointing to the smaller bar, then we will move the front, and if end is pointing to the smaller bar, then we will move the end. Again we will calculate it up till front is less than end. Okay, so this is our approach. Now we will look to its implementation. So as discussed, we will have int front that will point to 0, and int end that will point to HEIGST height of size minus 1, as we are dealing with indexes. Okay, now we will have int max capi cit by capacity, uh, capi cit by capacity is equals to int min. We are taking int min. Okay, so now what we will do, we will iterate while front is less than end. Okay, front is less than end. So what we will do, we will calculate current water capacity, okay, between these two. So what will be our vertical breadth? So that will be u minus l, that will be end minus front, okay, f, sorry, that will be multiplied with the minimum of height, okay, HEIGST height of front, comma HEIGST height of end. Okay, front and end. Okay, so now we will have to check whether it is maximum than that. So we have to store that maximum capi cit by capacity is equals to max of current capacity and what we have previously stored, max capi cit by capacity. So we will have maximum, we will, in this way we will maintain our maximum. Okay, now we have to check for another one. So what we will do, we will again, if we have to move our pointer. So if HEIGST height of front is less than HEIGST height of end, in that case we will move our front pointer. Okay, else we will move our end pointer. Okay, and we what we will return, retu and return max capi cit by capacity. Okay, so we will return maximum capacity. Now let's run this. So it is accepted. Now we can submit. So yes, it is submitted successfully. Now to discuss the time complexity of this problem, so what we have, we are iterating this height array one time using front and end pointer to the whole length. So its time complexity will be capital O of n, where n will be the size of this height array. Okay, so thank you for watching.